Hello everybody and welcome back. About 3 years ago I made a review video about this curious little 3D printer. It's the TronXY X1, and TronXY did something that not a lot of other brands did at that time. They made a 3D printer that was completely different than the rest. While all the other manufacturers were basically pumping out one i3 clone after another, they actually dared to be different. And it was quite a good printer, and it's aged pretty well. It needs some maintenance from time to time, but it's still printing as good as it did on its first day. And that is saying something. Well, back then this thing was a bargain at about, I don't know, about 115 euros, 120 euros, somewhere about that. And it's gotten cheaper all the time. But now that 3 years are over, why don't we have a look what TronXY has to offer at exactly the same price point. So for 116 euros I bought a new TronXY printer, and it's the XY-2PRO. And it just got here, so let's get it on the table. So here's the box. It says XY-2PRO, 11 kilograms, made in China, and as opposed to the original X1, the X1 was a kit. This one here is, so they say, minimal assembly required. So let's have a look inside and see how much is minimal. So I don't know what to expect of this, only that it's pretty cheap. I don't know if there's going to be any parts that are still the same as they were 3 years ago, but I suspect that maybe the extruder, the heater, the cooler could still be very similar, because not a lot has happened in the past few years. So what do we get? We get a leaflet, and it says only needs 3 steps to finish the rest installation. Filament, run out detection, resume, print after power off, auto level, all metal. Yeah, it's a little manual, machine parameters, a packing list, machine detail list, installation instruction. That looks okay. Operation and print, structure debug. Yeah. Wow. Manual leveling, software installation. Looks to be something Cura-like. Simple. So we also get a power cord. In my case, that is a European plug. We get something to get the prints off. Nice, it's sharpened, so oh yeah, it's really sharp. Be careful with that. You get the standard bag of bits and pieces. I see a screwdriver, I see another screwdriver, filament mount, a lot of cable ties, an Allen wrench, but I don't see, oh yeah, looks like there's part of the runout sensor or an end stop. Okay. We get a USB cable. I suppose it's about 1 meter. It's not the longest that I've gotten, but it's usable. And we've got a SD card with a USB adapter, and it's probably going to have the instruction on it and the slicer. Also, there is a pretty much decent amount of white filament. It's PLA, and it's 250 grams. That is a nice thing. There's so many printers that just come with this minimal bag of filament, and you know you're never going to use that. So, and that's it. Is it? No, there's a metal piece here, which that's probably part of the spool holder. And as we go deeper, we get the entire X and Z axis gantry, and we get a print bed material. Well, not too bad. I think we get either a glass cover for the heated print bed. No, we get one that is fiberglass material, and that's it. So what they want you to do is they want you to basically stick this on here, and there are some different manufacturers of this stuff, and usually at the beginning this sticks quite well, but not for very long, and in many cases it starts coming off the fiberglass, but that's okay. Now, continuing on our way down into the box, I think we can just take this whole thing out, and we have the entire gantry, X-axis and Z-axis. We have one lead screw, and well, we have the profile and pinch roller assembly. That is so common these days. And we have the extruder, and that looks somewhat like the old one, but this one has print bed cooling and extruder cooling and a level sensor. Okay. Now let's remove some more packing material. I must say this is well packed. Very nice. And there's nothing loose down here, so I suppose we can just grab the base of the printer and pull it up. That's it. Huh, that's everything. Flat ribbon cable to connect to the X-axis gantry and Z-axis, I think. We have the display mounted so it's out of the way and it can't get broken. We have a power supply, probably not a mean well, but something along those lines. All right, let's get it set up on the bench. So it's out of the box, it's on the table. It is really simple. There are 4 holes in the 20x40 profile, or no, it's a 40x40 profile, for a set of screws that is included, and that's gonna fix the entire gantry. there are Allen wrenches, so you can remove the display. And I am using the included Allen wrenches to get the display out, and then you can move it to the right edge of it. I don't know if this is actually made for right-handers and left-handers, but it would be interesting and nice if it would fit both sides. And well, I suppose it could. I don't know if the cable's long enough, but it actually has holes on both ends, so it would be easy enough to connect this to the other side. There are no buttons on here, so it must be a touch screen. And we can move this over there then. One thing that I'm seeing right away is the power supply is actually open on the top. That is probably for ventilation, which means you shouldn't actually clean the print bed with alcohol or water or Windex or whatever you use while it's running, because that stuff can run in here and cause a short circuit, or even worse, maybe connect the mains to the frame. But apart from that, it's really nice and simple. 40x40 profile, 20x40 profile, 20x40 profile. It's really sturdy. If you have a look at the Y-axis setup, there is a roller to make sure that the belt is absolutely parallel with the table, which is very good. That's exactly the way you want it. The only thing that I see is that this belt has a nylon sleeve holding it, and these nylon sleeves are prone to giving in after a few months. Have this thing get hot and cold a couple of times, that nylon sleeve is going to deform, and you're going to have this this roller hanging down. But you can just replace this with aluminum tubing. But apart from that, really simple, really nice. So let's get it prepared and let's set it up. I mean, even 3 years ago, the TronXY 3D printers were, well, different than the rest. Let's say it that way. And I actually like the kits a lot. And both of my TronXY printers are still in working order. And I reviewed the X1 in late February 2018, and I think the X5S that I have came in around, I don't know, May, and they're both still running. So the manual says you're supposed to place the display on the outside so it can't touch the heated print bed, which makes sense. It's kind of an odd placement. Many other printers have a slightly different setup for that. Is this the right tool for the job? Yeah. But you have to give them this. This is one of the cheapest printers like this. I mean, 116 euros for everything. We don't get a lot of evolution regarding 3D printers. The whole FDM concept is still pretty much exactly the same as it was in the beginning, but prices are dropping rapidly, and that is a form of evolution too. So let's see if I can mount this standing up. So basically all that you have to do is thread the screws from the bottom into the profile and tighten it. If that doesn't work easy enough, I might have to clear out the camera and do it off camera, but maybe it works. So all the cables are in the right position. Everything seems simple enough. And it's a nice setup, so they're not lying when they're telling you that it is easy to set up. Let's move this up just a little bit by turning the stepper. Turn this over so I can get the second screw threaded. And another thing that immediately pops up is the whole printer is absolutely clean. There are no metal shavings that I can see right now. There are no leftovers from the build process at the factory. It's just nice and clean. So now that we have the two screws set, we can tip it over. And get these in all the way. So regarding the parameters, build platform is 30 by 30 by also I think about 30 centimeters. It is a 24 volt system, so the times needed for heating up everything should be pretty short. There is nothing more to it. Apparently it accepts G-code for Marlin or Repetier, so it's no strange variant of G-code that it requires. And according to what they have on the internet, it works with any slicer, which makes sense because all the big slicer programs will output Repetier or Marlin G-code. So we have one side set up, and I just dropped the screws. Let's turn it over so you can see the underside. Oh, this is where the four screws go. 1, 2, 3, 4. Ribbon cable for the display and touchscreen. The controller is under here. Apparently they have provisions for having either other controllers or cooling for the controller and different set of cabling. Like I said, the power supply is pretty much standard. It is a unit that can do 220 and 110 volts, which is nice. The manual has a very big section telling you to actually examine it and have a look that it's set to the right voltage before you plug it in the first time, which is also a really good idea. I haven't seen a power switch yet. I'll go looking for that because I want my 3D printers to have a mains switch where you can actually disconnect it from the mains, because you never know what happens. So here we are. Let's have a look at the back of it. So here we have the back of the 3D printer. We've got a micro SD card. Unfortunately, it's located on the back of the 3D printer, which is never a good idea because, well, most of my 3D printers are usually set up so the back is towards the wall, and it's quite fiddly to get them in there. I would much rather have the micro SD card put into the display part of it. We do have a USB, so we can have online printing. We do have a power switch, very nice. Apparently it also has a fuse, but that looks very much fake. And we have a standard 3-pin power connector. Alright, so now that this is set up, we can have a look at getting the cabling for the X, Y, and Z axis. And this one's really simple because all you have is one ribbon cable, and this one does have an index, so you can't get it in the wrong way. And well, it's just as simple as that. Give it a push, latch it in, and you're done. What else do we have? We do have a filament runout sensor. We have an extruder driver, which is a single pinch affair. Pretty big driver here. The driver gear is smaller on the E3D or the TiVo Titan, for example, but this stuff works. The spring here puts a lot of tension on the filament going against the driver gear. If you have soft filaments, this may lead to some patterning in your prints, but I suppose for a printer like this it's okay. The PTFE tube is connected to the cable shroud. Sometimes I don't like that, but the PTFE is pretty short, and that is something which is always good because you have very little slack in here. There is a cable for the Z-axis stepper, and I'm just gonna put this into the stepper, and we're set up for that. And here we have the wire for the heated print bed, and that has its own cable shroud. It doesn't have a cable chain, so you can expect the cable in here to break after about 2,000 to 3,000 hours of printing, but with a lot of the printers it takes a while to get there. But then you have to basically remove the cable that is in here and add another cable. Looking in here, this cable seems to have a pretty good cable thickness to it, and there's also the sensor cable in here. Like I said, it's one of the cheapest printers. It's good. It's not excellent, but it's good. So what else? I am not seeing an X-axis end stop switch anywhere. And the cable management here is, yeah, that can't stay that way, because this is just going to start pinching the PTFE tube. Probably going to have to separate these two. So, oh yeah, here is the X-axis end switch. The Y-axis end switch is right in the back of here, and it's not going to have a Z-axis end switch because it has a sensor on one side of the extruder. Now, here's another part, which is the filament spool holder. Usually they want you to mount this to the top of the 3D printer, or to the Z-axis or X-axis gantry, and put this right at the top of here. And I usually don't do this because this adds a lot of mass to the frame right at the top, and it's going to aid in amplifying vibrations. Basically, it puts the resonance of the whole gantry, and there is going to be vibration on this from the movement of the Y-axis, and it basically it gives you a lower frequency resonance, and unfortunately you can see that in your print. So I am probably, if it works out, I'm going to try and mount this on the profiles that are right at the bottom of the printer, or maybe somewhere to the back. Also, because it is much easier to get the filament to thread, then I think I'm going to put it right at the end here, if I'm going to put it on at all, because I do have roller pucks or other stands for that. Okay, so let's prepare the heated print bed and get the printer ready to turn it on the first time. So I thought you might be curious as to what kind of a controller is in here, and I'm curious too, so let's just have a look inside while we've not used it yet. And let's have a look what we find inside, what kind of controllers they're using, if we can see adequate cooling, all these things. And they did make sure that you don't accidentally wander inside. These screws are on so tight, I actually have to break out the Allen wrenches to get them removed. And here we are. And this is a really, really tiny board. Let's get you zoomed in. So there are no power boards on here. Let's see if we can get this off. There is a fan where the driver circuitry is. There is what appears to be a super cap. I don't know why that is on here. Oh no, These are TMC 3225s, but they don't have any heat sinks on them, which I would think is advised. Apart from that, we have a 32-bit ARM microcontroller. So it's a simple 32-bit board. We've got a pretty long cable to the touch screen, and all the rest is well, pretty much standard. Small MOSFETs for the two heaters. I'm not sure if that makes a lot of sense. It would probably have been a lot easier or simpler for them to have added heat sinks to the TMC controllers, because they do tend to run pretty hot. So, interesting board. Nothing special, nothing really bad. Some of the power cabling up here is a little bit sketchy, because we have open connections back here where the where the fuse is supposed to live, and there's no fuse there. Yeah, but they did put a little bit of insulation above it, so it's a small effort. And apart from that, yeah, pretty much standard. Apart from it being 24 volts, so 24 volts means that we do have a lot of output power available, which is good. So let's put this back together and screw it back in place. And I suppose then we can try to turn it on. So this is Dirk from 3 Days in the Future, and I've done a little bit of research on a few of the things regarding the 3D printer. First of all, the controller board we found on the underside is a XY-2PRO controller. That explains the software that we're finding on here, which is also a variant of the XY-2PRO firmware. And there are some issues with this. The XY-2PRO firmware isn't bad in itself. In fact, it works okay, but it does have some shortcomings regarding the sensor. So my advice is always manually level this print bed, because the software does not have compensation for the location of the sensor, so your measurement will always be off by exactly the distance between sensor and nozzle. There are fixes available for that, but they're kind of manual. And if you do a manual calibration with the points always, and make sure that you don't damage your print bed or that it doesn't get warped, you will have the best prints, because compensation for the print bed height is only on the lower levels. So if your print bed is tilted at an angle, it will just make the lowest level and the highest level parallel. Everything between that is still going to be shifted. It doesn't compensate for that. And that is very important to know. The best thing that you can have is a perfectly aligned print bed, and then just rely on that. I've also learned that there is a definition file for Marlin for this controller, so you can update to Marlin, but before you do that, make sure that you obtain a copy of the original firmware, which is not on the SD card. And as far as I can tell, the only way to get that firmware update file is to contact TronXY, but apparently they're very forthcoming in that, and they will just send you a an update file. So you can keep updating using the update mechanism by just inserting the SD card with the correct firmware, and it'll update itself. If you break that, you have to fall back to getting a STM32 toolchain, and it does come with an uploader and a downloader, and you can then use that to dump your original firmware or to try to do an update with a slightly broken 3D printer controller, but it's a pain. And you need to obtain the correct bin files first, which are not freely available. So that is pretty important. If you want to do an update on this, make sure you have everything you need to go back first. The other thing that I found out is that this sensor that is on here is kind of known for having a slight temperature variant. So in my case, my workshop is currently at around 16 to 17 degrees Celsius. Once it becomes summer and we get up to 20 to 22, the leveling is not going to be correct anymore. So I'm going to have to re-zero this. Also, there is said to be a problem with the controller firmware sometimes losing the zeroing settings. That is just the original firmware. The Marlin firmware apparently does not have that. As far as I know, there is no version of Repetier for this, which is a shame, because I like that more. I was able to set up Repetier host settings for other slicers, Cura slicer, SkeneForge, and it just works out of the box. It's very nice. And the information provided in the manual right here for how to set up a printer, well, exactly this page here, reflection. So page 14 on the manual tells you how to do it, and you can do it with other printers and it'll work just fine. Yeah, and my issues that I had at first with the Z-axis being a little bit too tight, that went away after 2 or 3 prints. So right now I'm super happy with this thing. Okay, so it is all together. I suppose now we can do this here, and now I can remove the second one here. And let's have a look if they did a good job preparing it. Oh, so we're moving it back a little bit. Yeah, I'm going to take the angle meter and zero it on the table. And we're going to put it on the build platform and see if that is flat. No, it's 0.5 degrees off, and the gantry is actually at absolute 0. And wow, gotta get you focused in to see this. And a perfect 0. I haven't had that in a while, so if I can get this table to be absolutely 0 also, we should have a pretty good time getting this printer dialed in, because you want the printer to be absolutely flat to the table, so it needs to be so everything is at right angles. You want your x-axis gantry to be perfectly down to 0 now, or very close to that, and you want your z-axis to be absolutely 90 degrees, or in this case we're like at 89.9, somewhere about there. And those are pretty good values for cheap 3D printers. And so if everything is, if the table and the x-axis are perfectly parallel, then it is very easy for the probe to get everything set up correctly. And yeah, let's try and dial that in. So yeah, these are all the way out. So we are at 0 degrees here. Testing the table again. Yeah, we're getting there. 0.2. Perfect 0. So yeah, if we have it like that, we can power it on and do the manual calibration for the table. And then I'm going to put the build tack on the fiberglass, and that will need some time to set, so all the air between the build tack and the fiberglass can dissipate. If it doesn't dissipate, you can just turn the build tack over and heat up the heated print bed to somewhere around 80 to 90 degrees, and it will make the glue go all soft, and the air can then move away under that. It's a pretty easy thing to do. So yeah, let's continue. Let's get it working. So there are two things that I want to point out that I really like about this printer. The first thing is that the threaded rod sitting on here on the stepper is actually not on a flexible joint, but on a rather stiff one, so it doesn't have any play. Also, there is a ball bearing holding the threaded rod in place, and it actually has provisions, so this can be fine-tuned, so the gantry works absolutely perfect, and the distance between gantry and threaded rod is always constant on the side of the stepper as well as on the side of the bearing. And also the metal sleeve where the threaded rod goes through, that is actually mounted so it has a little bit of movement. So if your threaded rod has a little bit of a bend or it causes a slight wobble, that motion of the threaded rod, and they do have that often, can't actually propagate to the x-axis. That causes z-axis wobble, or kind of a vibration feature that you see in your prints. And if you don't want that, you basically make sure that your z-axis rod is held very firmly in place, and that everything else is kind of in a way loose, so any movement of the rod is actually not imposed to the X or Y axis. So I like that setup a lot. Once again, TronXY, they do know what they're doing, and that's a good thing. When I was going through the bags, I said I found a Z-axis or any axis end switch. This appears to be extra. Also, the PTFE tube holder, they seem to supply one of these in excess. That's not a bad thing, because they do tend to break. And this is the side that goes to the extruder. So, yeah, maybe they know something that we don't. Maybe these tend to break. I don't know, but it's a nice thing that they give you one spare. So, the printer is assembled-ish. I did add the build tack to the fiberglass and gave it some time to set in. And the next thing that I'm going to do is I'm going to move the Z-axis manually until it almost touches the print bed, and then I'm going to move the print head, the nozzle, to each and every spot where the adjustment screws meet with the heated print bed, and I'm basically going to move it into each corner and make sure that I have the same distance between the heated print bed or the build tack and the nozzle. And on these printers this is really easy to do, because you can just move the nozzle as close to the screw as possible, move it right there, and just go all around twice, and you'll have a pretty good result. The rest of the leveling is going to be done using the sensor, and the only thing that you really have to set up is the distance between the sensor point where it measures the platform and the nozzle itself. Moving it down till it almost touches, just a hair, and manually moving it all the way to the side and to where the screw is, as close as we can get it. And then we just move over, and we can see if we start touching the bed, or we can actually see that something else is touching where it shouldn't be. So, yeah. There we go. And we are touching here. Okay. Done. And same thing over here. And that was one strand. Okay, that is going to be good enough for a start. So once the printer has booted up and played this nice little melody, we're greeted with this very simple menu. System just displays system settings. You have info, what's going on right now, temperatures, stuff like that, information about the printer itself. You can mute the speaker and things like that. You have different languages, you can reset defaults, and you can adjust the touch screen. You have the tools section, which is the most useful of them all, where you can actually set up the printer. You can do the leveling steps where it will move to positions, and you can check that your levels are correct. And you can stop a running print, you can change the fan settings, and you can change your Z offset from the sensor, which is basically the most important thing, because your sensor is going to drift over time, and you can basically select the distance that you have where the sensor trips, where it sees the heated build platform, and you can set that inside the printer so it always knows how far it will still need to go down to be at the 0 position, because the sensor actually trips before the nozzle hits the build platform. And then you have the print menu, and there are several several G-code files on the SD card, and I think I am just going to prime the nozzle and let it print one of those. So let's go back to tool. Let's go to manual steps, and let's home the axis. It's actually doing that. Ooh. And it's actually touching these little clips when it's doing the homing. I don't really like that. Okay. So we're homed, and let's see if we can home Z to the minimum. It still seems to be off. So we'll have to go back, change the Z offset. And I'm going to put the Z-axis down now until it touches, and I hope that the sensor doesn't touch first, which is apparently the case. So there will be some further setup required. Oh yeah. I'm going to set this, but there is another step that I need to do. I'll show you. So the sensor is not absolutely parallel to the build platform, so I'm going to have to loosen the screws on that and make sure that it basically sits flat above the heated print bed. And that should allow me to set the zero position better. Now, where did I put that Allen wrench? Let's get this leveled. And then let's try again. Setting the Z offset, which means it's going to home all the axes. The stepper motors on this are really nice and quiet. So moving down until we almost touch, and that is really close. Really close between sensor and print bed, because you don't want to run into your prints with the sensor. Try this again and better this time. Now, if you didn't see it before, there are two screws here, and I just made sure that the sensor is absolutely parallel to the print platform. And once that is the case, I can manually guide the nozzle until it almost touches the print bed. Set this as 0, and we're done. So we can manually move up a little bit and start a preheat cycle for the extruder and print bed. So the default temperatures for the extruder appears to be 223 degrees and 73 for the print bed. Yeah, so it's actually doing a pretty nice job. And the advertising is correct. I mean, this is really simple to set up. Just a handful of screws, and everything else just sort of fell into place. It's kind of nice. So we're actually at layer 2 now, and yeah, it's picking up speed. And it looks to be doing its thing. So let's let it run for a while and then come back. So a short update at 11% of the print. I didn't realize that this rook is actually sliced in 0.1 millimeter layer height and might take some time. But what I can see right now, and I must actually say I am literally amazed, is it's pretty much perfect. There's absolutely nothing to complain about. In fact, this print looks really great. So it's sliced absolutely perfectly. It seems to be one of their let's show it off parts, and it looks really good. It's going to take a long time until this is finished, and I'm just going to let it run. But it has very little infill, it has very thick walls, and the 3D printer is doing all of that absolutely perfectly. And so this is like, I don't know, it took me like 20 minutes, half an hour to set it up, including filming it. So this is a really good result, and I'm just gonna let it continue. So I'll bring you back tomorrow when it's done, because it's quite late now, and I'll just let it run. So 9 hours and 5 minutes later, the print is done. Let's have a look. That actually looks quite amazing. It is really, really nice. We can see some issues, like a little bit of stringing up here, but that can usually be fixed through slicer optimizations. Let's see if I can get it off. Well, it sticks well. Yeah, this is really, really nice. Great surface, no ringing. I can see a little bit of stepping artifacts on the outside here, but this is really nice. If we take a look at the staircase inside here, it is very clean, apart from a little bit of stringing. And I think it managed the overhangs pretty well. Unfortunately, it's really hard to see in there. But man, what a first print. I didn't set anything up. I just fed it some old filament that I know is good, and I let it have at it. And it's really nice. So this rook is kind of a torture piece. It is usually used for resin printers to show that they can do overhangs and that they can do very small structures, but it also works for FDM printers. And well, usually I have a demo piece that is a lot smaller than this, but this came out really nice. The only thing that I can see is that the first layer appears to be rather compacted, and the issue with that could be that the Z-axis, that the pinch rollers haven't run in yet, and they're still a little bit tight. So it might be that there is a little bit of slack in the Z-axis, but over time that is just going to fix itself, because that just gets so much run in, and then it goes away. But wow, that is really, really nice. And 9 hours, that's a good time. So this was sliced at 0.1 millimeters layer height, and I think they have very good slicer settings on this, because there do not seem to be any start-stop artifacts on the outside, which would cause little blobs in the print. Also on the top, you can see that all the layer shifts and all the shifts between the little posts here were all on the inside, so that is a very good slicer setting. But it also shows what the printer can do. And the overhang here is absolutely clean. So, wow, great success. And there is a small helical coil right in the middle of this rook, and it appears to be intact. It has quite a lot of stringing, but as I say, stringing is very much dependent on the filament that you use, and it is caused by not retracting enough filament when you're moving through air. So it might just have a little bit of filament still on the nozzle, and it's going to just make these small strings and draw them over. But first of all, they can be cleaned off, and second of all, you can have settings that don't do it that much. Oh yeah, but what a nice thing. Really like it. Really, really like it. And yeah, the printer did a super job. Yeah, these just come off really easy. And you can either just pluck them off or take a carpet knife or a scalpel and get them off. Oh, there are some start-stop leftovers inside here. Oh, this seems to be the seam for the start-stop, but yeah, it's really minimal. Also, the overhang in the door came out quite well. And maybe you can see the little helix inside here. It's there, but there's a lot of stringing around it. But it's not broken. So, great result. I like it. So let me quickly sum up what I think about this 3D printer. First of all, it is pretty much a perfect set. You get everything you need to start 3D printing. I haven't looked at the software, but 3D printer software and slicer software is freely available, and this printer works with Cura and Slicer and SkeneForge, so you do have a choice there. I like that it has a level sensor, and I like the build quality in general. Everything fits very tightly. There is no slack or play in any of the parts here, and it kind of shows that TronXY has been in the market for good printers for quite a while. And yeah, this is just one of the things. It takes experience to make a good printer. What I also liked was that putting it together was very simple, and the pre-alignment of all the parts, the way they came out of the box, was very close to perfect. So if you know how to use the tools, you will be able to set up this printer in like 20 to 30 minutes, and you will be able to start printing then. That is very, very nice. Apart from that, the parts themselves are pretty much standard. It has a very standard extruder driver. The extruder itself is tried and true. It's 24 volts, so it will be pretty quick to warm up, and it has a pretty good response when something is changing or when you need a temperature change with some filament. It will respond really quickly. What I didn't like is the power supply, the way it's mounted, and that the vent openings are accessible from the top. So you must make sure never to spill any liquid onto this machine, or you might be in trouble. The display, the touchscreen, I'm not a real friend of those, because, well, it's got a 32-bit controller, but the only thing that you really need that controller for is the menu, and the rest of the operations don't really require such a advanced controller. What is good, though, about the controller is that they're using TMC drivers, and these are really, really silent. So the fans are more loud than the rest of the printer, and the fan for the power supply keeps turning on and off, but it's not annoyingly loud, so that's fine. The rest of the parts, like the runout sensor, the end stops, and all of that is absolutely standard. Tried and true, good parts. So I think this is, for the price, a really, really good printer. I don't think that they cut any corners with this, but at 116 euros delivered, I don't see how they could go cheaper with this. I really don't. So my verdict of this is a very, very nice entry-level printer. It is very well constructed. It is very sturdy, and all the parts are just as good as they need to be. If the build tack holds out, we'll have to see over time, but these surfaces have evolved quite a bit, and they've been improving over time. Regarding print quality, my first demo print turned out so well, I really don't know what to say. It's close to perfect. So, and it shows off what this printer can do. And I think that is that's the best thing that you can say about this printer, is that with the first print it just showed off what it could do, and it did that very impressively. So my verdict about this is it's a really, really great entry-level printer. It's constructed well. It is very solid. 40 by 40 extrusion material and 20 by 40 makes for a really sturdy frame. The Z-axis gantry is very sturdy as well. The rollers for the Z and X-axis came perfectly aligned, and if they go out of alignment, it is very easy to get them aligned again. And the manual that came with the printer was actually helpful. There are others that are not, and I really have to say it's a nice set. It came with the spatula, or well, with the print removal tool. It came with an adequate amount of filament. 250 grams is enough to do your first and maybe second, third, and fourth 3D print, and that's fine. It's really good. The SD card that came with it worked. The adapter worked. The tools that are included are the tools that you're going to need to maintain this printer, and starting out, I suppose that is exactly what you need. So a very, very nice printer, a great price, and I think with the black and blue, those are my favorite colors, it even looks good. Yeah, that's it. That's my review of the TronXY XY-2PRO. It is quite amazing how far we got in 3 years with two printers that came at the same price. The first one was barely a printer, but it did print well. And 3 years later, you get the complete set, 32-bit controller, silent TMC stepper drivers, 24 volts, heated print bed, height sensor, auto leveling. You get the whole thing at the same price from the same company. So I really like this one, and I think I'm going to be using it a lot. Looking at the quality that I'm getting, I might actually convert it to a smaller nozzle and have it do finer prints. I think this thing can really do it. So that was it. Thank you very much for watching, and bye-bye.